Now, let us move on to the next segment, that is common factors. So, what do you understand by common factors? Before knowing this topic, we should cover what are factors. So, what are the factors of any number? We have already discussed in the previous segment. The factors basically means if I take a number 12, then all the numbers in which table the number 12 occurs, right? So, we know it will occur in the table of 1 also, because 1 times 12 is 12. Similarly, I can say it will come in the table of 2 also. 2 6 are 12. Similarly, I will say 3 times 4 is also 12. I will relate it 4 times 3. Now, here it is a repetition. After 3, it is 4 times 3. So, we can stop over here. That means we can say it will come in the table of 1, 2, 3, 4, 6 and 12. So, all these numbers are the factors. You can go back to the segment, the previous segment of the same chapter where we have already discussed about the factors of a number, right? Now, here when we are dealing with the common factors, so we need to have, let's see an example here, like what are the factors of 4 and 18. So, you know, the factors of 4 will be 1, 2 and 4, because 4 will come in the table of all these 3 numbers. And what are the factors of 18? 18 will come in the table of 1, it will come in the table of 2, then 3, then 6, then 9 and then 18, right? So, after writing the factors of all these numbers like 4 and 18, we can relate here the common factors of 4 are, the factors of 4 are 1, 2 and 4 and the factors of 18 are 1, 2, 3, 6, 9 and 18. So, what are the common factors here? The common are 1 and the common factor is 2. Is there any other factor which is common? 4 is here but not present in the factors of 18. So, it is not the common factor. The common factors are 1 and 2 and we say they are the only 2 which are the common factors of 4 and the number 18. Now, moving ahead with the next segment, what are co-prime numbers? After knowing about the common factors, it becomes very easy for you to understand co-prime numbers, because co-prime numbers are the 2 numbers which have only 1 as a common factor. They are called as co-prime. For example, if you take 4 and 5, so 4 and 5 are called as co-prime numbers, because the factors of 4 will include 1, 2 and 4 and the factors of 5 will be 1 and 5. And what are the common factors here? So, the common factor is 1. So, we can say 4 and 5 are the co-prime numbers. But now, remember one thing, very important point that you need to recall here. See, 4 is not a prime number, but 4 along with 5 will be a co-prime number. So, for a co-prime number, it is not at all necessary that the numbers need to be prime. They may be prime, they may not be prime. For example, if I take 2 more pairs like 5 and 7, they both are prime as well as both of them are co-prime also. The factors of 5 are 1 and 5, the factors of 7 are 1 and 7 and the common factor is 1. So, yes, all the prime numbers, all the set of prime numbers, we can say since they will have only 1 as a common factor, so they all will be the co-prime numbers. Along with it, if you take suppose an example 4 and 9, they both are not prime numbers, but factors of 4 are 1, 2 and 4 and the factors of 9 are 1, 3 and 9. What are the common factors here? The common factor is only 1. So, although 4 and 9 are not prime numbers, but they form a pair of co-prime numbers. So, I hope the co-prime number concept is very clear to you all now. Don't be confused between prime and co-prime numbers now. Okay. Now, moving on to the next thing, that is common multiples. Again, to know, before this topic, we need to know about multiples. So, if we multiply any number, we get the table of that number as simple as that, or we get various numbers which will come in the table of that number, right? So the numbers which are occurring, which are coming in the table of a number, we call them as the multiples. Like the multiples of 2 will be 2, 4, 6, 8 and so on, right? We have already discussed the topic multiple in the previous segment. Please go and watch that as well. Now, moving ahead with the topic here, common multiples. What are the multiples of the number 4 and 6? So we can write the table of 4 and we can write the table of the number 6. So 4, 8, 12, 16, 20, 24, they all are the multiples. And how many multiples can be there? There can be infinite, because there is no stoppage here, right? There is a starting but no ending thing here when we write the table of any number. Similarly, the multiples of 6 will be 6, 12, 18, 24 and so on. And here we observe that 12 is a factor which is, it's a multiple which is common in 4 and 6. After 12 we find there is one more multiple, 24. And in the same way, when we proceed with this, you will find many multiples which are common, right? So 12, 24, 36, they are the multiples of both 4 and 6. That means these are the numbers which are coming, which occur in the table of both the numbers 4 and 6. And if they occur in both the table, we call these numbers as the common multiples of these two numbers 4 and 6. Now, you can relate one more thing here. Let's say after 12 you have 24, after 24 you have 36. Can you relate what will be the next number in the series? Yes, you are right. Here, what will be the next number? We have 12 2s are 24, 12 3s are 36. So we have 12 4s are 48. And we will continue the table of 12. So we find here that the common multiples are 12, all the numbers which occur in the table of 12 also, right? And from here we'll arise to one more topic, that is a least common multiple, and from the topic of factors we'll come back to the highest common factor, that is the concept of HCF and LCM. Now, after doing the topic of common multiples, let us move on to the next topic. And here we have some more divisibility rules again. There are certain rules other than all the divisibility rules of 2, 3, 4 and so on. We have few more rules, or we can say these are the few important points which we derive from the divisibility rules also. Like for this, the first rule may be, if a number is divisible by another number, then in that case it is divisible by each of the factors of that number also. So very simple, let me take an example. Suppose if I take the number 24, okay, then in 24, what are the factors of 24? So I can say it is divisible by 2, it is divisible by 3, by 8, by 12, right? So let me take one of the factor. It is divisible by 12. Fine. Now let's see what are the factors of 12. So factors of 12 are 1, 2, 3, 4, 6 and 12. Alright. Now what do you understand by this? This rule states that if a number is divisible by another number, that means if 24 is divisible by 12, then it is divisible by each of the factors of that number also. That means 24 will be divisible by all these numbers also. That means 24 will come in the table of 1, 2, 3, 4, 6 and 12 also. You may take any other example also and try the same rule with the number. Suppose let me take one more number, say 36. So I can say 36, factor of 36 is 18. Okay, and let me write two factors of 18. So two factors of 18 are 3 and 6. So according to this rule, 36 should also be divisible by 3 and 6 also. That shows if a number is divisible by any number, then it should be divisible by the factors of that number also. And you can relate the same rule to many other numbers also. Let's move on to the next rule, which states if a number is divisible by two co-prime numbers, then it is also divisible by their product also. Now, what do you understand by co-prime? We have already done in the previous segment. that co-prime numbers are the numbers which have their common factor as only 1 and there is no other common factor to it. For example, we have taken 4 and you can take 9, right? So 4 and 9 are the two numbers which are co-prime. That means if I say a number is divisible by the two co-prime numbers. For example, if I take a number, suppose 72. So 72 is divisible by both 4 as well as by 9. That means then it is divisible by its product also. That means now if I multiply 4 and 9, the result will come out to be 36. So 72 will also be divisible by 36 by the product of the co-prime numbers. So 72 will also be divisible by 36. Similarly, you can take any other number. Suppose if I take 50, just let me take 50 only, okay. What are the factors of 50? Now factors of 20, factors of 50, that means in which numbers 50 will come? It will come in the table of 1, it will come in the table of 2, it will come in the table of 25, even it will come in the table of 5, it will come in the table of 10. Now select any two co-prime factors out of it. Co-prime factors means the factors which have only 1 as a common factor. So can I select 25 and 10? No, they are not co-prime factors because they both come in the table of 5. That means the common factor here is 5. So it is other than 1. So we cannot take the factors combination as 25 and 10. Let me take another number, say 2 and 25. Can I take this number set? 2 and 25? Yes, they are co-prime because they don't have any factor which is common in them. So will 50 come in the product of these two co-prime factors? So 25 times 2. So 2 into 25 will give you again 50. And yes, 50 is divisible by 50 also. You may try with one more example, say 2 and 5. So if I take the number 2 and 5, just check, are they co-prime numbers? Yes, they are co-prime because they have single number as a single number 1 as their common factor. So here we can say, since they have a common factor 1 and their product is 10, so 50 is also divisible by 10. So I think this part is also very clear, that if a number is divisible by any two co-prime factor, then it will be divisible by their product also. Next rule more for the divisibility rules is, okay, let me take one more example from the previous one here. The number 80 is divisible by 4 and 5, right? So it is also divisible by 20, like 4 into 5, 4 5s are 20. So it should be divisible by 20 also. Now the next segment here is one more divisibility rule, that if two given numbers are divisible by a number, then important thing, then their sum is also divisible by that number. For example, 16 and 20, they both are the numbers which are divisible by 4. They both come in the table of 4, so they are divisible by 4. And here the number, their sum, that is 16 plus 20, which gives you 36. So here 36 is also divisible by both the numbers. 4, is it? No, yes, it's divisible by 4. So the sum of the two numbers, that means final, after doing the addition, what result you are getting, that number will also divisible by the individual number. So this is one more rule that we have done. Moving on to one more rule for this is that if two given numbers are divisible, then their difference is also divisible by that number. For example, if 35 and 20, they both are divisible by 5, then the difference of 35 and 20, that is 15. So 15 will also be divisible by 5. So if a number is divisible by both the numbers, if two given numbers are divisible by a number, then it should be divisible. In the previous one we have done by their sum also, and also by their difference. So these are two important rules which you use it in your prime factorization method also, right? We will be dealing with that segment also in the later segments here.